Good morning, students. I am Gopal, head of the Department of Humanities and Science. So, last three classes we have to resolve the given rational fractions into proper fractions. Okay. So, here today we have to discuss the method 3. The denominator contains one non-repeated linear factor and one non-repeated irreducible quadratic factor. So, means, for example, x square plus 3x plus 2 equal to 0 is given. We have to find out factors of this equation by using this method. So x plus 2 plus 1 half x plus 2 equal to 0 implies x plus 2 into x plus 1 equal to 0 means, so this is the polynomial. So we are having the two real factors. So therefore it is said to be reducible equation. So for example here x square plus 2 equal to 0 is given. We cannot find out the real roots of these kind of equations. These equations are said to be irreducible quadratic equations. Example, one more example, x square plus x plus 1 equal to 0. Here also we are not getting the real root. So therefore these kind of equations are said to be irreducible. This is power 2b, so that's why it is said to be quadratic equation. If this kind of factors contains the given rational fraction, we have one of the method. Yeah, now we will see this example and how to find the partial fractions of this rational fraction. Yes. So now solution. Resolve into partial fractions. Yeah, now given rational fraction is 2x square plus 3x plus 4 by x minus 1 and x square plus 2. And check it, this is also proper fraction. Okay, so therefore 2x square plus 3x plus 4 by x minus 1 x square plus 2 equal to. So first we have to return this linear factor a by, this is the one of the quadratic. Now this is the linear factor. It is non-repeated linear factor, but it is not a linear factor. Okay, this is quadratic equation and this is irreducible quadratic equation. And as for example, some of the quadratic equations are given. Now these kind of quadratic equations are given. We have to return these are into the linear factors by using the similar method. These are the linear factors of the given quadratic equation. But this is also x square plus 2 equal to 2 is also quadratic equation, but it is irreducible quadratic equation. If g of x is contains this kind of factors, which quadratic equations, we have to return here bx plus c by x square plus 2 means, so this is we have to return x minus a. This is the one of the linear factor. This is another quadratic equation. We have this g of x contains two factors. First one is one non-repeated linear factor and one non-repeated quadratic equation. Yes, quadratic factor. So this is a by x minus. So this is linear. So that's why we have written only a. If irreducible quadratic factor is given, this is the expression. How to written this expression bx plus c. Remember? So this is the key point here. We say that this is equation 1. And we have to find out both sides LCM. So 2x square plus 3x plus 4 by x minus 1 x square plus 2 equal to a of x square plus 2 plus bx plus c of x minus 1 whole divided by x minus 1 into x square plus 2. And we cancel both sides denominators, and this is implies to, this is say that this is equation 3, 2x square plus 3x plus 4 equal to a of x square plus 2 plus b of bx plus c of, this is plus x minus 1. Yeah, this is equation 2. Now we have to find out these constant values a, b, c. Here the three values are now. We have to find out these three variables a, b, c. We have to find out these constant values by putting either x equal to 1 or x equal to 0 or something. Here first we put x equal to 1 on both sides. Both sides we get 2 of 1 square plus 3 of 1 plus 4 equal to a of 1 square plus 2. Why? Because this is x square. So plus b of 1 plus c 1 minus 1. And this is implies to 2 plus 3 plus 4 equal to. So this is a of 3 and this is completely 0. So that's why this is completely 0. And this is implies 9 equal to 3a and it implies a equal to 3. Okay. Now next we have to substitute x equal to 0. Put x equal to 0 in equation 2. Yeah, we get 2 of 0 plus 3 of 0 plus 4 equal to a of 0 square plus 2 plus b of 0 plus c and 0 minus 1, and this is 4 implies 4 equal to 2a plus this is 0 and only c is there, so this is minus c. But we know that a value 4 equal to 2 of 3 minus c, and this is equal to, you shift this into this side and this is into this side, c equal to 6 minus 4 equal to 2. We get c equal to 2. And we have the one more constant value. We have to find out one more constant value. Okay. Yeah, already we find out a value and the c value. Now we have to find out the remaining value b. We compare and both sides x square coefficients here. So in this equation, we have to compare x square coefficients on both sides. Here, left hand side x square coefficient is 2, and the right hand side a into x square, ax square. X square coefficient is a, and here b into x, bx into x, bx square. X square coefficient is b, and we have to substitute a and b values here. Already we don't know b, but we know that a equal to 3. So therefore, we have to substitute here. And therefore b equal to, shift this into this side, 2 minus b equal to minus 1, b equal to minus 1. And we get a value, b value, c value. We have to substitute in equation 1. So therefore 2x square plus 3x plus 4 whole divided by x minus 1, x square plus 2, and this is equal to, we have to substitute these constant values. Here a equal to 3 by x minus 1, then we have to substitute b minus x plus 2, c value 2 by x square plus 2. Now this is the resolve the given fraction, the given rational fractions into proper fractions. Now students, please remember here the denominator g of x is contains one non-repeated linear factor and one non-repeated irreducible quadratic equation. Dear students, this is the one more example. X square plus 1 by x minus 2 x square plus 4. In the given rational fraction, g of x contains one linear, non-repeated linear factor, one non-repeated irreducible quadratic equation. Yeah, we have to return partial fractions here. A by the linear factor plus bx plus c by irreducible quadratic factor. Okay, if g of x is contains non-repeated irreducible quadratic factor, so that's why in the numerator we have to write bx plus c. Now as well we have to find out LCM of the right hand side. x minus 2 x square plus 4. Now here now what is the LCM here? X minus 2 x square plus 4. So that's why. So we have written only x square plus 4. A quotient is x square plus 4. And then bx plus c, this one. And this denominator is x square plus 4. So that's why we have to written this is the coefficient on this one. Okay, x minus 2. And we cancel both sides and denominators. So we get in this equation. Now this is the key equation. Right. Now in this equation, a of x square plus 4, bx plus c, x minus 2 is there. In order to find a value, so bx plus c coefficient reduced into 0. Means we have to put x equal to 2. Put x equal to 2 in equation 2 we get. Means if we put x equal to 2, this becomes to 0. So completely this from bx plus c, this is completely becomes to 0. So we getting a value. Yeah. Now x equal to 2 means, yeah, left hand side we have to substitute x equal to 2 square plus 1, a of 2 square plus 4 plus b of 2 plus c 2 minus 2. This is becomes to 0. Means finally this is completely 0, and we have only 4 square means 4 plus 4, 8a, 5 equal to 8a, equal to 5 by 8. So this is the first value. And in order to find any one value, either c value or b value, we have to put x equal to 0. Means this b is become to 0. So that's why we have to put x equal to 0 in equation 2 we get. Means we have to substitute left hand side x equal to 0, 0 square plus 1, a of 0 square plus 4 plus b of 0 plus c of 0 minus 2. So therefore this is becomes to 0, and this is 4a, left hand side only 1, 4a, and c minus 2 is there, minus 2c. Now in this equation we have to substitute a value. What is a? A equal to 5 by 8. A equal to 5 by 8. So 4 2s are 8. So this one cancel, we get 2. So 1 equal to 5 by 2 minus 2c. We have to shift this into this side and this one into right side. 2c equal to 5 by 2 minus 1, and LCM is 2. So 5 minus 2, 3 by 2c equal to 3 by 2, and this is implies c equal to 3 by 2 into 2 means 3 by 4. And if we find out the c value and a value, we have the one more value, that is b. In order to find that value, we compare on both sides x square coefficients in equation 2. So left hand side x square coefficient is 1, and right hand side x square coefficient is a, and the x square coefficient is b. X will be x square, 1 equal to a plus b. And already we know that a value, a equal to 5 by 8. So therefore b equal to 1 minus 5 by 8. LCM is 8 minus 5 and 3 by 8. We get a value, b value, c value. We have to substitute all these values in equation 1. Yeah, now we will see this one. So this is equal to, what is a? What is a here? A equal to 5 by 8. 5 by 8 by x minus 2 plus, what is b? B equal to 3 by 8 into x. And what is c value? Yeah, already we find out c. This is c. C equal to 3 by 4 plus 3 by 4 by x square plus 4. And finally this is equal to 5 by 8 of x minus 2 plus, yes, this is 3 by 8 x plus 3 by 4 by x square plus 4. And this is the process of finding partial fractions of the given rational fraction. Now students, now these are the assignment problems. X by x minus 1, x square plus 1. Here one is non-trivial linear factor and this is irreducible quadratic equation. And similarly here, this g of x is contains repeated linear factor, means x is repeated twice, x into x, means we have to written here a by x plus b by x square plus cx plus d by x square plus 1. Why? Because this is irreducible quadratic factor. So now this is the process of finding solution of this one. Then find out A value, B value, C value and D value by using either substitution method or comparison method. Okay, now this is the examples, now assignment problems. Now students solve these assignment problems and upload in Witsconnect app. Now next class we shall discuss one more method. Okay, thank you very much.